So okay, so we are I am learning ownership in Rust. So I am sharing my journey with you guys. So my first week target is um, learn ownership types, error handling, um, first week task, and uh, ownership borrowing and lifetime basics are my first goal, and I have to complete in 2 days. Okay, let's start um, this part. Okay, let's start this part. And okay, so first we so my core concept is Rust is a vast language, right? I have to focus on 20% Rust thing that can use in 80% places, so that I can master Rust and I can be productive in Rust as soon as possible. So my goal is 1 month. I have to complete my journey. Uh, let's say Rust 20% things I have to complete that, and after that um, I have to jump into the project. Okay, so I am following two site, that is for Rust learning. I am following this rustexercise.com, uh, and for concept clearing I am using this site, and for practice this is the best resource in Rust. You can see here is Rust fundamental, 76 question, and control flow have 15 question, and Rust standard library have 55 question. So let's start my journey. I already complete that 76 question, fundamental question, but I have to revise it. That's why I just pick a core Bible for Rust, so that I can clear my concept from this book. And um, late after after 6 months, if I need any concept, I can search in here. You can see all the topics in Rust. If you master those topic, you can productive you can be productive in Rust. So let's start the journey. So first is ownership. So ownership, you we have ownership rules here, that is data never muted while it being readed. Data is never readed while being muted. So data is never um, uh, accessed after it being destroyed. So those three are the borrow checker rule. So borrow checker is the guardian or police that will save you from from any crime or any harmful things. Okay, okay, so that means our borrow checker will remember. Borrow checker will go through these rules, and after that it will give you. Okay, so I have to remember these three rules. So what these three rules means. So first, data is never muted while it's being read. Okay, that means data is never muted while it's being read. This is the data, and it is read by a person. But uh, when a person is reading this data, you can't the person B can't mutate the data because the person is reading. Okay, that's easy. Data is never readed while it's being muted. So here you can we can see muted person A muted the data. You can't read that data in that time. Okay, I understand that. Person A can read, person B can read when the data is deleted. Okay, the theory is too much easy, but the I think it will tough in the implementation. Let's see what is going on. So yeah, from implementation perspective, um, we have two things. We have a example. Here you can see we have two variable, variable 1, variable 2, and let's see what is going on in this file. Okay, so this is the variable file. So I just write this in the main function because I want to execute this file. So okay, so one thing that is, if we want to run this file, main file, we can run this like single file. On the other hand, we can write cargo go BRU and run. Let's see what it just say. Okay, yes, we can run this in hello world. Okay, and we can also check check check. What check do? It will run without compile. That means without compile. If I delete this, you can understand what just I said. Okay, it is checked and it is it checked the file. If I want to run this now, it build and run. So that means we have the hello world function. So if we implement borrow checker rule in this place, what will happen? So they just said you can't read when it muted, right? So let's say if we mute it, uh, what happened? Oh, sorry. Cargo warning. So yeah, remove this mute. Okay, so if we use here a, what will happen? What do you think? You will see this error, that is borrowed of move value. That means a is borrowed in B, the ownership is transferred to B, is A ownership is transferred to B, and you can't use A because the A is not owner. after transferring the owner, a is empty, and a is not empty, a is totally banished from the memory. So uh, in Rust we don't have um, borrow check sorry, we don't have garbage collector. That's why this variable is now deleted from the memory. There is nothing. Now we can use this if we use clone, CLO and clone. So that means we just clone this clone um, A's value in B. So now it is okay, but if we want to um, print A, it can't, because Rust just stop, Rust borrow checker just stop in runtime, sorry, compile time, right? So B is okay. This is called, this is the this is rule A, right? Rule A says that you can mute it, you can read data, you can't read data when it muted. Okay, so we just see the execution string. So Rust system function in the signature, how it want to interact with the argument. So far all our method and function have consumed their argument, they have taken ownership of them. For example, um, okay, implement ticket dispatch, take ownership from ticket intent it call. This is known and moves and take ownership value of variable is moved from the call to anymore. Okay, okay, so here is the implementation. If we use this str structure to get, okay, if we write a structure and implement it, and this structure they are saying that um, public function dispatch self string self description. Okay, so um, ownership of the residual which move ticket. Description. So okay, so we have to write main function in front, main. Okay, so here, okay, that is great thing to do. So here what we are doing, we we just took um, ticket a structure, and we have string, title, description, that is also string, and status, um, string from opening. So what is going on in this place? They said that um, you ticket move due to this method called ticket move due to, here is the ticket. Ticket has type ticket which does not implement the copy trait. That means we does not implement copy trait. That's why ticket move due to the method called print. Okay, okay. Let us ticket the title. Okay, that is great. So we are facing same problem here. So use of move value ticket, mm, ticket has been moved, and the value used is after moving. That means uh, when we use okay, what it is telling us, that means when we use this, and um, here uh, here we can see the title just received the ownership of this ticket structure, right? So this ticket is been passed in this implementation. So that means the ownership has been passed to this implementation. This title, this title function, right? Yeah, that is okay, that is the question. So line 3, 30, 36, 37. In 30, a move occurs because ticket has typed ticket which does not implement the copy trait. So ticket does not implement the copy trait. If we use copy trait, then it will okay. Okay, so ticket move due to this all method, um, because of this part. Okay, because of this part, the ticket value has been moved. Okay, that means we can't pass value in this. If we want to pass this value, we can use copy thread, but we didn't. That's why the borrow checker stopping us in compile time. So this is the core concept, right? That should be the core concept. I understand that. So okay, if we use copy thread like copy, copy, if we use sorry, copy, okay, If we use a clone thread, then okay, sorry, I thread copy thread leader, implement the copy thread. That means we can use clone, but it is not memory efficient. We can use self. Here I am learning the errors, because error is the core concept. If I understand the error, then I can execute in future. So that is not what it said. It is saying me that self. If we give reference, what will happen? So if we solve this, fix this problem, what um, should be the answer, right? So okay, we will use this error to our AI. I will say WSY this error or okay, and so how to LV this. Okay, we are using AI for fast solve. They are using reference. Why not copy? Okay, right. So that is so I have to find out what is copy thread, right? Copy thread, because I think that can be a um, is it not okay, this can be evidence of deep thing. Algorithm behavior. Okay. Okay. Algorithm. Okay. Copy. Okay. Not copy. So here is string is not copying. That means our if we use copy thread, it won't um, solve our error, because copy thread use in this type of things like integer, floating point, boolean, character, not in string, right? Not copy. Okay, that means we can't use copy thread. We can also use in tuple, right? Tuple, great. Reference, okay, that means we can't use copy thread in this place. That's why our error didn't vanish. Let's use this copy thread. Is okay. I think the error has been vanished, right? We can check this. Sorry. Sorry. I think I just used wrong. Okay. So what is just saying that training can be implemented for this type. That means I can't implement copy thread because copy thread is used only when that is integer, floating, boolean character, reference, tuple, array. Okay, that is good that is great information for learning. So copy thread implicitly bitwise duplicate automatically explicitly method called clone. Okay, that means when we use copy thread, in that time it will copy line by line, right? That means it will copy line by line, line by line, line by line. But when we use clone, we have to call the clone with the string, right? Like let's say e dot clo and clone, uh, like that. No, like that. Okay. um okay, so we have to use um, another method. So clone, we have to use clone thread explicitly from outer side, and if we want to um, okay, okay, so that means that is clear. It can be used in string or vector, um, or any stack that contain heap allocation data. Okay, we can use copy or clone. Okay, now we have to use reference. That means we have to um, use reference, and we have to call it reference. um, so we are using reference. That is why our error, that okay, sorry, the error has gone. So this uh, copy implementation error has gone. Let's check out. um, Finish, yes. Run. Okay, so we just compile with Rust using borrow checker rule. So what the rule says, that we have three rules, only three rules. First is you can't use mutable data when read it, or the opposite when it reading you can so after destroying you can access this um, this concept we just see in this line, right? So after moving the ownership, you can't use it in here. So uh, third rules implemented here, and first rules, that is you can read, implemented here. We use first, FIRST, first RULA, rules of ownership, that is mm, it is never read, it is muted one. Muted. Because when we transfer the ownership, you can't mute it, or you can't read after this line, in this line. So we just implement these two rules, and we have left one, so we can mute it. So if we mute something, we can read that explicitly. We will see in future. Let's say after borrow checker, we saw ownership. Now we wanna see borrowing. So there is two things. So already we see the mutable reference, using this reference in our implementation here. um, okay. So okay, we just found borrowing. So we will start borrowing. That is, it is described to have method can read the value of variable without taking ownership of the program, would be quite limited. Otherwise the rust that done by borrowing. Okay, so main concept is you can borrow, when you borrow a value, you get reference are triggered to be triggered with the privilege. So ownership is easy thing, right? You give the ownership of variable, and that is on the end of the cycle, right? But I think borrowing have some critical things, because borrowing concept is too much rusty, right? Let's see what is going on. Mutable reference, immutable reference, that means you can change, allowed you to read value, but not mute it. That means mm, you have the mutable reference. That means you have the mutable reference. Uh, um, reference allow and value not muted mutable reference. Okay. Person may allow you to read muted the variable. Okay, you in only reference you can change uh, the variable, but mutable reference you can change the variable. These two are the main core rules. So we have to see the restriction, right? So going to go Rust ownership system. Data is never muted while it being read, never read it while it being muted. So these are the golden rules of Rust. And borrowing. So what is going on? No. Okay. So okay. So ownership system. Okay. Okay. Mm, you can't mutable reference. Okay. They set some rules to ensure the borrowing borrowing concept, right? So you can't have mutable reference and a mutable reference to the same value at the same time. um, you can't have more than one mutable reference to same value at the same time. You can't have a mutable reference and mutable immutable reference to the same value at the same time, right? So first is this rule for specially customized for. Okay. Mhm. So we have this special line. You can't have mutable reference and immutable reference at the same time. So if we use this template, let's say uh, this is mutable reference and mute baby REF reference root immutable mm, immutable uh, can mutable reference. You can't have mutable reference and immutable reference at the same time. That means this is the data and you can't have uh, no, um, MTL, reference R A R A F reference and uh, mm, yeah, A sorry REF reference. So first is you can't have immutable reference. Okay, you can't have immutable reference and mutable reference at a time, right? You can't have this. Okay, that is great. That is great. Okay, so this is the first condition. Second condition is you can't have more than one mutable reference to the same variable. Okay, second condition is sorry You can't have more than one mutable reference to the same value. That means um, that means if I use this template, it will like um, you can't have two mutable reference. That means you can't have two mutable reference at the same data, right? You can't have two mutable reference at the same data. Sorry. Mm, okay, you can't have same mutable reference. Okay, that is red. That is good. You can't have same two mutable reference at a time. The second condition is just saying that. So owner cannot mutate the value while it's being borrowed. The owner cannot mutate the value while it's being borrowed. That's mean it will slightly change, I think. The owner. Okay. Mm, okay. Here, what we are seeing, the um, owner can't mutate the variable. Now we will see some difference. Look, okay. So let's say this is the owner. No, is the muted reference, and this is the owner. O W N O W N. Yeah, owner of the data. Just changing the connection. So this is the data, data, and here we have the sorry for the inconvenient. So okay. So here um, and muted it, you can muted t t muted. Okay. So the owner, this is the owner, the owner can't muted the the value while is being borrowed by this person as one person a borrowed person A borrowed the data. So we just see three concept of borrowed. First is mutable reference. You can't use two things at a time, mutable reference and immutable reference, and you can't use two mutable reference at a time. Okay, another thing is ownership. So owner can't modify the um, data while is being borrowed by person 1. Okay, so last and the final is you have you can have a same immutable reference as you want, as long as there are no mutable reference that is the same as the first rules. That means uh, you can use immutable reference as much as you want. I have many immutable reference as much as you want, but if there is mutable reference, you can't do that. Okay, let's see what is going on in this concept. Okay, okay, so here is a structure configuration um, that is about uh, versioning version 1 and 2. So B is percentage of Q, since it contain a reference to okay. So what is the B is a reference. B is a reference of version field of the type of B is now this dimension is unnecessary. It is just to clarify what is going on. Okay, so if we want to see print and print version B, if we want to print version B, then what will happen? Build, we have to build it first. Okay, we just build it and we will RU and run. So version 1 is version B is 1, right? So we just borrow, we just have a reference in B. We have reference of version in B, and that was A where is a uh, active. So we will check two things at a time. Let's see, version 1 and var active is true. Now if we uh, let's say mute, so there, that this is the example they just given to us, and you can see we just borrow config version and active from this configuration variable, and after that same concept apply to the function argument and return type. Okay, f take a mutable reference to u32 as a argument bound to the same number. Okay, okay, so they just give us an ownership example. We should, sorry, we should visit this and find out what is going on. So they just give a complex, so here what is going on, we have structure, that is ticket, and we implement the structure in here. So new, okay, okay, so we just have a new function that will create a ticket, and here is the title to check what is on the ticket. Okay, we should check out and play with this in our code editor. Let's see what is going on in this. Okay, do we find any error? Yes, we just we already solved this problem. um, we already solved this problem in the ownership part, that is we will use reference, only reference, right? We will use only reference. Now you can see, um, okay, sorry, not test, we will use main, because it is not our live.rs file, it is main.rs file, right? fn main.rs, so we just use main.rs file, not live.rs. So here you can see we just take this structure and push this on our structure, and the ownership model, here they just said ownership model, we just use a reference in the ownership model, that's why our value is not moved. right? So we can run this and find out. mm, mm, okay, we just have we just run the program, and we use reference is we just find out reference in borrowing concept, that we have two types of reference. One is immutable reference, another is mutable reference. So that's it. um, let's check out. So um, okay, so now we have to find out a lifetime. So so lifetime. Okay, we just um, we just have lifetime. So lifetime should have a another video, because lifetime is um, too vast topic, I think. So we will cover it in the next video. Hopefully you just learn something from this video with me. I am also a newcomer, but I am trying to learn Rust um, as soon as possible, at as fast as possible. And the core thing is I am following this um, this 80-20 rule. That means we are using 80% uh, 80% of 20% of concept, it used in 80% places syllabus. We are using this syllabus. So if you want to join or learn with myself, then uh, feel free to connect with me, and that's it. So um, hopefully we will complete this journey in 1 month. So today I just done ownership and borrowing part, and hopefully I will complete this part today or tomorrow, and I will give you all the resource I am using